Hi, everyone. Thanks for the introduction. And I'm really excited to bring you a talk. Afternoon sessions always a lot of fun. I hope everybody's coping here. The best part about this is the question that will come, well, what is a chief revenue officer giving technical talks at OpenSearch for? I don't blame you for that. And let's make it interactive. We're not a full hall. So let's see by way of hands. Who here runs OpenSearch clusters? Okay, great. How many of you that run OpenSearch clusters have ever been in a situation where I can't do what I need to do because it's costing too much? You ever had that? There we go. As engineers, one of the key things that we want to do is want to focus on performance. We want to focus on stability, on our use cases, on our infrastructure, and we scale. And we always seem to reach a point where we get to it's costing too much money. I can't get any more hardware. I can't scale it. But I'm responsible. So what do? I've spoken to literally thousands of companies over the years. OpenSearch has been in the market since January 21, correct? Since January 21 is only just over two and a half years ago. So most people on OpenSearch today moved from something. There are a few new use cases, but most of you, let me see, who's migrated from something to OpenSearch? There we go. And the number one reason that we get from doing that, of course, is we always want to be on the open source, and that's really valid. But there's always a subtext there. And the subtext is how am I going to reduce the costs? We all scale, we all have costs. The most important thing that we're going to cover today in reducing costs in OpenSearch is how we can be good engineers. We can concentrate on performance, we can concentrate on operations, and we can optimize our costs. So our clusters can be as good as they can be without that added pressure of, we can't really take care of the cost of this. So I'm going to just tell you a few things about Opster, which is going to give some nice context for us to go forward. The first thing to know is the use cases, the solutions that we're about to see might change your perspective of what it is we need to concentrate when we run in our OpenSearch clusters. And it's been developed against 20,000 users, against some of the largest companies in the world, and of course, some very small companies. And we started like most OpenSearch engineers would start. Let's concentrate on the performance, let's concentrate on the speed, let's concentrate on the stability, until we realized that the cost is impacting all of that. It's impossible to scale without taking cost into consideration. So the Autops platform, which gives us all these great insights, does anybody use Autops or Opster tools here? Okay, great. So it will optimize the performance. It will help you to reduce the costs. But as good as that is, we are very large contributors into the open source community. This is what we're all about today. So we've developed projects like the Kubernetes operator for OpenSearch. It's one of the largest projects in the open source community with many, many different contributors. Very proud of that. In addition to that, we've given some really cool stuff. We've built on a management console, which gives you a user interface for the Kubernetes operator, completely free for anybody to use. We've built really useful community tools. We're going to brush on that a bit later, completely free for the community to use. So we're going to go to real life examples today We're going to show the possibilities, and we're going to give you tips from actual case studies whereby we can optimize the cost of our OpenSearch clusters, and we can do it for a minimum investment. So I'm going to give it over to Ziv, and Ziv's going to run through some real customer stories from in the trenches, fighting the war, and what happened. Here we go, Ziv.
Thank you, Bianca. So nice to see you all here. And like Bianca said, I'm going to discuss some use cases that we collected from working with many customers. And what I like about the use cases that we choose to display here is that they're very simple to follow up and implement. And you're going to see that in the key takeaways of these cases that everyone can actually implement them. They're pretty simple, but they're very powerful. So just before I start, I want to emphasize something that Bianca just mentioned. As an engineers, when we work on a project, we mostly care about the functionality. We want it to run and we want it to work efficient. And that's the main goal, the first one. And then after a while, we want it to scale as well. And we need it to scale if it's a successful project. And then cost comes in. And cost can be very dangerous for the success of a project, because if you don't take care of that, the project might fail because of that. So that's important. So let's drill down to the cases. First use case. This is a large security deployment use case on OpenSearch. This customer started small, as any successful deployment on a large organization, it started expanding to more and more use cases. So that OpenSearch cluster started small and became really big, with many data streams coming from thousands of hosts and different applications in the organization, all shipping security information into the cluster. So everything was working fine, and functionality was there. There was dashboards and alerts, and everything was set up correctly. But after a while, they started noticing that the ingestion load was more than they expected. What does that mean? Of course, you always start a project with doing some capacity planning, and you know what you're going to expect. But then reality comes in and things start evolve. So that ingestion load was much higher than they expected, and they didn't know what's causing that. And they needed to throw more hardware on that problem. And as we know, hardware costs money. So we analyzed that cluster with AutoOps. And interestingly, we found out that out of hundreds of data streams, there were 2 data streams that were responsible for about 75% of the load, the ingestion load. Again, that sounds like very obvious and simple thing to do. You say, well, I know my data, I know my data streams, I can tell you right away what's causing the load. But the point here is that things change along the way, and they didn't expect that. So we actually have a visualization that's become part of the product, and they've seen visualize that 2 data streams, as you can see, are responsible for about 75% of that load. Once we show them that, the insight drives the solution really quickly. The security guy said right away that these 2 data streams are not that meaningful. They didn't have alerts set up on them and small amount of visualization. And we could quickly drop most of it and reduce that significantly, that ingestion. So out of hundreds of data streams, 2 was causing most of the load, and just optimizing that allow us to decrease the load by 50% and then reduce some of those nodes that were needed for the extra indexing. So again, the takeaway is very simple here. You need to monitor the system. You need to check it and do that repeatedly, because things change Someone likes that integration that you just set up and is going to deploy to 100 more hosts or thousands of more hosts, and then the capacity planning you did has changed. So you always need to monitor things, visualize things, and understand what goes on. So the major step toward the solution is to understand what's causing this thing, and just visualizing it will help. We'll have time for Q&A in the end, so feel free to ask questions once we get there. So let's move to the second case. This one is an observability use case, also very large cluster, multi-tenant, meaning lots of different use cases all flowing in that logging and metric cluster. And the design, initially, cost was important, so they used data tiers in order to reduce cost. That's a good way to reduce cost. Another good tip, if you can utilize data tiers one way or another, that's very helpful. So they did plan to reduce the cost by using data tiers. The initial plan was to have 1 day of hot data. It's a cluster with lots of data flowing in every day. And then another 6 days of warm data, where most of the queries are on the first 24 hours, and then 6 more days for additional query performance. And then after a week, data was flowing to nodes that were utilizing searchable snapshot. So again, it started out well. When they deployed the cluster, everything was working smoothly. And similar to that previous case that I mentioned, after a while, they started noticing that they need to add more and more resources to the hot tier. So the hot tier was expanding, and as you know, hot tier are the most expensive nodes in the cluster. They need to take care of the indexing and most of the search. So the most expensive nodes in the cluster, they needed to scale that group constantly. So we analyzed that cluster, and we found out that reality was different than the plan. So the plan was to have 24 hours in the hot tier, but we found out that some indices and index patterns were actually having indices in the hot tier for 5 and 6 days. Again, there's a lot of data on that platform in every 24 hours. So in the reality, they had much more data stored in the hot tier, and storage was running out, and they needed to add more and more nodes there. So if you think of that, it's very simple to detect this, that you wanted to move the data after a day and it didn't move for 5 or 6 days. You say to yourself, that's a simple thing, I will catch it right away. But think of a large deployment where you have thousands of streams going into a cluster. It's very hard to manage that. Very hard to find the noisy ones, especially when behavior change after all the time. Some streams are low in traffic, and then after a while they become very bursty, and so on. So what we did, let me go back for a second. We analyzed it, and like I said, we found that some index streams were running for 5 and 6 days in the hot tier. When we analyzed it deeper, we found out that the index state management policy was not running as expected. Technically, they were rolling over the indices, but on some cases it rolled just by size and not by time, where you can do both. So if you're not aware, you can roll over the indices every certain amount of time, like every 24 hours. Even if the shards are still small, you can roll it in order to move it between data tiers. And they didn't have that setting set up right. So we fixed that index state management policy, and that helped us reduce the hot tier significantly. So the takeaway here is always verify that your plan and the reality are the same. You think, and when we talked to that user, he was 100% sure that data is 24 hours in the hot tier and it moves, and that was clear to him until we found out that some of the patterns were not running as expected. So you always need to verify that and check, especially when it's a large system. Okay, let's move to the third use case. This one is a completely different use case. The first two were very large deployments, multi-tenant, hundreds and thousands of data streams that hard to manage. This one is the e-commerce use case. And as part of that, they use the data content and entities, meaning you have, for example, that was flights related systems. So it had prices and routes and flights and airports. And once in a while, it needed to update those documents. And as you're probably aware, when you update documents in OpenSearch, there's a residual storage that is still there after you update a document. So updating a document actually creates a newer version of the documents on a new segment, and that older version is marked as deleted, but it is still counted in terms of storage. It is still there in that previous segment where it was indexed. So when you update a document, you actually have two copies of that, the older one and the newer updated one. And once you have a cluster running for a long time, that was running for years, doing updates on the same indices, things becomes really odd, you can say. So let's talk about a metric that we use to examine this case. It's the deleted docs ratio in an index. So the deleted docs ratio in an index is looking at how many docs are deleted in the index. It's a stat and metric that is available in OpenSearch compared to how many documents there are active and live in the index. So on that specific use case, we found some indices that have 90% of deleted documents, meaning, let's say you have an index of 100 gigs. So 90 gigs out of it is actually deleted data that is not used, taking away your storage and requires more hardware to handle that. So how do you fix that? There's a way, of course, to remove those deleted documents. It's called force merge. And in the merge process, the deleted docs are being expunged. And there's actually another parameter that you can add to that command that only expunge deleted documents and does not merge the segments, which is lighter in a way. But still, it's a good note to point out that when you run force merge, it's usually disk I/O and throughput intensive, and it might affect the performance of the cluster once you're running it. So it's very important to force merge indices on low traffic times. It can be nighttime, weekends, whenever you feel comfortable that it will not cause any performance degradation. And on that case, what we did was running that on a weekend and on a not too large cluster. I think it was roughly 20 nodes cluster. This is a real life story. We were able to take down 2 nodes. It was more than, it was about $1,500 a month saving just by running this operation. So I want to point some more things about it. You can say, hey, I understand that tip. I'll do it once. I'll go over my cluster, check where I have deleted docs, run a force merge, and I'm done. That will definitely help, but there is an advantage to do that periodically, especially if you're doing lots of updates on your clusters. You would like to once in a while check the deleted docs ratio, making sure you don't have lots of residual storage that you can take away. So I think the takeaway here, as the rest of them, is very simple. These are not rocket science algorithms that you need to take care in order to reduce cost in the cluster. These are simple steps, like monitor how you use the cluster, see what's going on, check that your assumptions are happening as you expect them, verify it along the way, and always do that repeatedly because things change all the time. These are simple rules. You can call them best practices, but they can impact significantly the success of your project. So, handing back to Bianca.
Yeah. So before we move on, thank you, Zev. I feel honored that it's your birthday talk, talking about our customers' experiences.
Thank you.
And by the way, if anybody would like to give birthday gifts to Ziv, I will gratefully receive them. But let's get back to seriousness. We didn't come here just to give you customer horror stories and how we resolved it and problems. We've come here today to think, okay, how can we resolve this? What is the best way to do this? And I guess for most of us in the room today, it's a case of, here's 3 examples, but we all know to optimize costs. Every cluster, every environment is very individual. Finding the best way to do it. If there is a best way to do it, where do I start? What do I look for? What do I do? Maybe I'm already optimized. How do we know that? And we want to do that in a way that we can prove it, not to get philosophical, but if you can't show it, it doesn't exist, right? So then we can move on to talking about, well, what are the ways that we can do this on OpenSearch? And we can do it easily, we can do it efficiently. And the best part about it is we can take it and report it. And we can go to our executives and our managers, and when they say, this cluster is costing us a fortune, look how much is it scaling. Wouldn't it be great if we had something to just say, it's completely optimized here. Take a look. Can I please get some more budget? And then you're not handcuffed into trying to perform miracles. You can scale the business, you can scale the cluster, you can optimize, you can operate, and you can put the cost optimization to the side. So if we look at this dashboard, we started years ago with the performance, with the stability, and more we started to empower our customers on AutoOps to look for cost optimizations. So on this dashboard, you can see very clearly all of the great events that are happening on an OpenSearch cluster. You can see the stability of the cluster. You can see a bird's eye view of the health of the cluster, but you also can see a few very informative columns here. You can see clearly potential savings, how much the cluster costs every month. Super easy to configure. You go into the cluster, you push where it is, assuming that it could be on AWS or Google, Azure, it doesn't matter. The package that you're on, the type of machines you got, and then it's a few clicks, and this will calculate it all the time, automatically. It will show you also how much you could save per cluster and how much you have saved per cluster without you worrying about calculating this externally. Once you get into the details meaning you jump from the bird's eye view of all your environment, all of your clusters, and you dig into the actual recommendations on the cluster level itself. Now, how many of you run environments with multiple clusters? Okay, cool. So now that you've gone from your bird's eye view and now you're into your individual clusters, so they say, well, I can see that it's not optimized. You've got 5% to go. And you say, yes, but this cluster is optimized, and this one has got X projects. So it's important to be able to drill down. Of these events, the events in green that you see are cost insights. The cost insights, there's many of them for many different reasons. So that whole question of where do I start? How do I optimize the clusters is solved, because there's something running on your environment that's saying you're not optimized here. This example, coincidentally, by the way, not by design, is very much in line with your third example, Ziv, where you've got a whole lot of deleted docs on an index. And that, of course, is taking up disk space. What do I do about it? Okay. It's all come here, and we then give the recommendations of how to fix it. This is really simple to see. Of this index, 60% of its storage, deleted documents, doing nothing but costing us money. Nothing worse than paying for money doing nothing, right? It's one of those bad investments. So we want to make it better. AutoOps will generate the resolution steps to get this optimized. And you'll see here Ops GPT. And has anybody ever used Ops GPT? Think of OpenAI, but getting its specific context against your cluster itself. So the answers are very, very specific, and you can interact with that chat. And you can say, it's a very easy question here. How can I resolve there's many deleted documents that can be removed? How can I fix this issue? And it will actually tell you, but it won't only tell you, it will generate the curl command. Obviously, we want to run a forced merge that gives you the solution, not just the problem. We can copy it, we can paste it, we can run the command, and then it gives you what are the advantages, but also what are the disadvantages, because every recommendation you have things to be careful of. Now, a forced merge is very IOPS intensive. So if you run it at peak times, it's a super dangerous action to perform. So you might want to run this one out of peak hours, maybe if your traffic goes down on the weekend. After you've performed the forced merge, your cost will be optimized. Once it's optimized, this event will automatically close and it would roll up into the amount of money it saved you. So remember what I said a few minutes ago? It's going to just take a little printout and it's going to say it's optimized. And I found it. What we're doing is we're giving some really, really simple, small steps that can make all the difference in your ability to run, operate, optimize all of your search clusters in an efficient way. This is a AutoOps platform, right? This is a platform from Opster. We spoke about community. So what happens if you're not an Opster customer? How can I do it? It's actually quite simple. The first and easiest way is you could go to opster.com. You can push on free trial. And for 2 weeks, it will analyze the places you can optimize your costs. You can see all of these events. Won't cost you a cent. Take them, use them, and optimize your costs. That's free. It's 2 weeks, but it's free. Another way you can do it is you could run our configuration checkup community tool, completely free. And it'll give you recommendations on optimizing your costs. No cost at all. There's actually a free community tool which is specifically for cost optimization. You can run that against your cluster as well. It'll give you recommendations specifically about what we've spoken about today. Of course, the choice, if it's important enough and you want to keep it optimized, we can, of course, try and help with that as well in terms of the AutoOps rollout. But all of these options for the OpenSearch community are available. And if you wanted to take it further, you could. And if you wanted to use it and optimize your environment easily and not pay any money, you can do that as well. Completely your choice.
So, yeah, just to summarize the technical points that we went through, except for the platform, is the way that we describe here, based on the use cases, is checking up what's going on in the cluster, what's going on under the hood, which index patterns, which data streams are the noisiest one, detecting those and acting upon, checking the configuration, the index state management, the snapshot management, making sure they work efficiently for you, and checking the data all the time and verifying whether that's deleted documents, or maybe you can cut down the retention of older data that can be on searchable snapshots or just not live on the cluster. Of course, there are many other ways to save money, whether it's upgrading older versions to newer ones,
I'd like to provide a few just high-level differentiators. The first differentiator is Opster is not a managed service. The AWS OpenSearch service is amazing. It will host infrastructure, scalable features. Opster will simply give you the visibility and ability to optimize and run the managed service or self-hosted. Okay. The next differentiator is between the free tool set that we have and the AutoOps platform. Never mind the one is free and the one's not. But think of it like a snapshot and a movie. And that's the difference. You can upload a file and you can get the cost insight. You get a checkup configuration. But what the continuous metric beat AutoOps platform is giving you is a more proactive approach. So you don't have to wait for the cluster to break to see there's a problem. You can follow the trends. And you can see the context of what's happening because it is a constant flow.
So thank you, Bianca, for that. Sorry, we ran out of time. If you have more questions and you want to see the solutions and how to save costs, we're here outside and you're welcome to our table to see that. Thank you so much.
Thank you, everybody.